Hello everyone, welcome back to our channel. Today, we're going to solve a mathematical problem step by step. The problem is, solve for x in the equation. Square root of 2 raised to power x equals to 64. Let's dive right in. Our equation is square root of 2 raised to power x equals to 64. To solve for x, we need to get rid of the square root. We can do this by squaring both sides of the equation. Squaring both sides, we get square root of 2 raised to power x squared equals to 64 squared. This simplifies to Since the bases are the same, the exponents must be equal. Therefore, x equals 12. And there you have it. The concept of exponential growth in solving equations like square root of 2 raised to power x equals to 64 has several real-world applications. Here are a few examples. 1. Compound interest in finance. In finance, compound interest is a classic example of exponential growth. The formula for compound interest is A is equal to P1 plus R over N to the power NT, where A is the amount of money accumulated after N years, including interest. P is the principal amount, the initial amount of money. R is the annual interest rate, decimal. N is the number of times that interest is compounded per year. T is the time the money is invested for, in years. For example, if you invest $1,000 at an annual interest rate of 5% compounded annually for 10 years, the formula becomes A equals to 1,000 times 1 plus 0.05 to the power 10. This is similar to the exponential growth we saw in the equation 2 power x. 2. Population growth. Population growth can also be modeled using exponential functions. The formula for population growth is Pt is equal to P0e to the power RT, where Pt is the population at time t, P is the initial population, R is the growth rate, T is the time. For example, if a population starts at 1,000 and grows at a rate of 3% per year, the population after 5 years would be P5 equals 1,000 e to the power 0.03 times 5. 3. Bacterial growth. Bacterial growth in a culture can be modeled using exponential functions. The formula is similar to population growth. Nt equals N0e to the power RT, where Nt is the number of bacteria at time. N0 is the initial number of bacteria. R is the growth rate. T is the time. For example, if a bacterial culture starts with 100 bacteria and grows at a rate of 5% per hour, the number of bacteria after 3 hours would be N3 equals 100e to the power 0.05 times 3. 4. Radioactive decay. Radioactive decay is another example of exponential growth, but in this case, it's exponential decay. The formula is Nt equals N0e to the power negative lambda times T, where Nt is the amount of radioactive substance at time t. N0 is the initial amount of radioactive substance. Lambda is the decay constant. T is the time. For example, if a radioactive substance starts with 1,000 grams and has a decay constant of 0.01 per year, the amount remaining after 10 years would be N10 equals 1,000 e raised to the power negative 0.01 times 10. In all these examples, understanding exponential growth and solving equations like the square root of 2 power x equal to 64 is crucial for making accurate predictions and decisions.
Thank you for watching. Like, share and subscribe.